Good evening. This is the presentation of the question 3 of my CBT assignment, and it's about geometry distribution. So first of all, let's take a look of this question. The annual number of southern Atlantic hurricanes follow a geometric distribution with mean 6. The number of landfalls on the Brazil East Coast per hurricane is distributed as follows. So the M is represent the number of landfalls, and this is the probability of landfalls, which is from 1 to 6 only. Compute the probability of 6 or more landfalls as a result of these hurricanes in the next year. So the question asks us to find the probability of m larger or equal to 6. But since it's very hard, so we direct use 1 minus probability of m less than 6. So let h equal to the number of South Atlantic hurricanes and m equal to the number of landfalls. So the question said, given the h follows a geometric distribution with mean 6. So first of all, we need to determine which geometric distribution we need to use, because there are two types of geometric distribution, which is one start from n equal to 1 and one start from n equal to 0. So this is the difference between them. Obviously, as you can imagine, since hurricanes can be start from 0, so we directly use the geometric distribution start with 0. So given that mean equal to 6, so mean equal to 6 equal to 1 minus p divided by p. So we will get p equal to 1 over 7, which is probability of success. Next, we can write down the PMF of the hurricanes, which is probability of h equal to p times 1 minus p power h, which we already count that p equals to 1 over 7. So after that, we can compute the hurricanes from 0 to 5, because we just need to find the probability of m less than 6, which is only result by hurricanes lesser than 6. And the question given probability of landfalls, I just list out here. So I compute a few of tables, which is provided the landfalls number, the probability, the m given that h equal to 0, and the probability of m given that h equal to 0. So first, we got 0, 1, 2, 3, 4, 5 landfalls, and as given that the landfall given that hurricane equal to 0. So since there are no hurricanes happen, so we have no landfalls, of course. So the landfalls is surely 0. So a probability of landfall given that there are no hurricane result in 0 landfall is 1, and the others are 0, because we only happen nothing, which is no landfalls, because we have no hurricanes. So the probability of happen nothing is 1. And the second table, the landfall given that the hurricane equal to 1, and the probability of landfall given that hurricane equal to 1. So when you have the one hurricane, of course, you will happen something. You will have landfalls. So they are not possible that we have no landfalls. So the 0 part is nothing. The probability of landfall equal to 0 is 0. If we have one hurricane resulting 1 landfall, so we are having 1, which is 0.65. This one. When we have one hurricane resulting in 2 landfalls, so of course the hurricane is only 1, so which is 0.15. This one. And then we list out all the probability here until 5. And for the third table, landfall given that hurricane is equal to 2, and probability of landfall given that hurricane is equal to 2. So the number of hurricanes is 2 in this case. So the landfalls have minimum must be 2. We cannot have 2 hurricanes, but we only landfalls 1. It's not possible. We can't make it. So the minimum of hurricane is 2. So the minimum of the landfalls also must be 2. in this case, when we have two hurricanes, so we can having two landfalls, which is one hurricane resulting in one landforce and another hurricane resulting in one landforce. So this overall is two. So how to calculate the probability of it? As you can see, is 1 and 1. So we use 0.65, which is the probability of m equal to 1 power 2. Because we have 2 times, so 0.65 times 0.65 is 0.4225. And for the three landforce by resulting from two hurricanes, we can either one hurricane resulting one landforce and another one hurricanes resulting two landforce, or we can the first hurricane resulting two landforce and another one hurricane resulting in one landforce. There are two possible. So we can use 0.65 times 0.15, which is the probability of m equal to 2, and plus 0.15 times 0.65 is about the permutation. So it's 0.195. The others are the same way. So I will not explain more, just calculate it. Okay, so for the fourth table, also the same, but you have to remember when the hurricanes is 3, the minimum number of landfalls must be 3 also. We cannot make it lesser than 3 because it's not possible where the hurricanes have 3, but you only landfalls 2 or 1 or 0. It's not possible. So as I said just now, there are 1, 1, 1 resulting in 3 landfalls from 3 hurricanes. So it's 0.65 times 0.65 times 0.65, which is 0.274625. And the others are the same. Okay. Yeah, this is the same also. As I said just now, hurricane is 4, so the landfall is minimum is 4. Hurricane is 5, the landfall's minimum is 5. So I will stop it here first, and I would like to discuss about to give you a big picture about it, since I scare you guys might be not understanding what I'm saying. Stop sharing. Yes, I will use a diagram to show you guys what I'm talking just now. So I will use the Malaysia map. Okay. For example, if I have one hurricane only, one hurricane, okay, one hurricane. So resulting minimum only have 1 or 2 or 3 or something until 5, okay, as I said just now. So if the hurricane is resulting in, for example, Penang, so maybe I can have only one landfall in Penang and then I just disappear or what. I also can make it as 3 landfall. For example, I from Penang and then go to Perak and then go to the south of Perak. Yeah, these 3 landfalls. So one hurricane you can be 1 or 2 or 3 or 4 or 5 landfalls, etc. But if you have, for example, 3 hurricanes, okay, from Kelantan and Kedah, and the Kedah and the Ipoh, okay, and the Perak, and the north of Perak and the east of Kedah. If you have 3 hurricanes, you cannot make it as 2 landfalls only because you have 3, 1, 2, 3. There are minimum 3 landfalls. But you can be resulting in 4, 5, and 6, 6, 6, 3, 4, 5, 6, 6, 7, 8, something like that. So means that if you are having, for example, 5 landfalls, means that maybe you Kelantan, these hurricanes can jump to Terengganu North, 1 landfall already. And then you can from Kedah jump to Perlis, maybe another landfall. So we are totaling 1, 2, 3, 4, 5 landfalls. So the hurricane must be the landfall. Yeah, the landfall must be greater and equal to the hurricane's number. Okay. I hope you understand what I'm saying. So now go back to our question. I will give the final solution for now. So after the discussion and the calculation, we got the probability, we know that probability of landfall less than 6 must equal to probability of landfall less than 6 given hurricanes times the probability of hurricanes. And then we expand it since the hurricanes is from 0 to 5. So the probability of M less than 6 equal to probability of landfall less than 6 given that hurricanes equal to 0 times probability of hurricanes equal to 0 and then plus probability of landfall less than 6 given that hurricane equal to 1 times probability of hurricane equal to 1 and plus until hurricane equal to 5 from 1 to 2, 3, 4, 5. So after compute, we got the probability of landfall is less than 6, which is 0.443719356. And then the questions require us to find the probability of landfall greater or equal to 6. So we must use 1 minus the probability of landfall less than 6, which is, we got our final answer, 0.556280644. And thanks for watching. I hope you understand what I'm saying and what I'm presenting. Appreciate for you to come to watch my video. Thank you.